Hello physics students, this is Mrs. Buchanan, and this is the first in your flipped classroom videos. In this unit we're going to cover Newton's 3 laws of motion, but within this chapter we're going to start with the most basic one, which is his first law of motion, which is also known as the law of inertia. So I want to review real quick the big idea for this chapter only, and forces cause changes in motion. If you see a ball at rest in the middle of a flat field, you know it's in equilibrium. No net force acts on it. But if you suddenly saw it begin to move across the ground, you'd look for forces that don't balance to zero. If there's no wind and nobody kicking it, you might look to see if someone was pulling the ball with a rope or pushing it with a stick. You would reason that something was causing it to move. We don't believe that changes in motion occur without some cause. So we'll review real quick the learning objectives. You copy those down in class with our first Powtoon video. So our learning objective number 1 is describe Aristotle's concept of motion. Now Aristotle was the most famous philosopher, scientist, and educator of ancient Greece. He was the son of a physician who personally served the king of Macedonia. At age 17, Aristotle entered the Academy of Plato, where he worked and studied for 20 years until Plato's death. He then became the tutor of young Alexander the Great. 8 years later, Aristotle formed his own school. His aim was to arrange existing knowledge in a system, just as Euclid had done earlier with geometry. Aristotle made careful observations, collected specimens, and gathered together and classified almost all existing knowledge of the physical world. His systematic approach became the method from which European science later arose. After his death, his many volumes of notebooks were preserved in caves near his home, and later sold to the library at Alexandria. Scholarly activity came to a stop in most of Europe during the Dark Ages, and many of the works from Aristotle were forgotten and lost. Some of his texts, however, were reintroduced to Europe during the 1000s and 1100s and were translated into Latin. The Church, the dominant political and cultural force in Western Europe, at first prohibited the works of Aristotle, but soon thereafter the Church accepted them and incorporated them into Christian doctrine. So, Aristotle believed in 2 types of motion: a natural motion, which on Earth it would be straight up or straight down. It is not related to topography, which is the lay of the land. Objects would seek their natural resting places, natural for heavy things to fall and light things to rise. And he also believed that there was a circular motion for the heavens, and he believed that that was also natural. So he believed in a geocentric universe. And what this was that the earth lays at the center of the universe and everything else revolves around it. All celestial bodies revolve around earth. We call that geocentric. It was a circular path, so it was in a circle. It was uniform motion, and the heavens had no beginning and no end. Okay, so this geocentric universe theory lasted for thousands of years, believe it or not. So he also believed in violent motion, and I showed this example with our bell ringer in class as well. It's an imposed motion. It's an external cause. It's an external force. So it's a result of forces that are pulled or pushed. So if we go back to our example of the ball laying in the flat field, then if someone kicks it or pushes it, or if there's an earthquake or some big wind comes along, that would be considered a violent motion. It is imparted to objects or applies to objects. Objects cannot move themselves, so they have to be pushed or pulled in order for them to be moved. If an object was moving against its nature, then a force of some kind is responsible. Proper state of objects was one of rest, pushed, pulled, or moving toward their natural resting place. The earth did not move, so the earth was the center of the universe and everything else revolved around it. Now remember what I talked about astrophysics, and that's what this is talking about space and relating physics to space and space back to physics. Our next learning objective is to describe Copernicus's idea about Earth's motion. So keep in mind that Aristotle believed in the geocentric model. Earth is the center of the universe. Okay? So Copernicus went totally out of the box here, and he believed in the heliocentric model of the solar system. Copernicus was a 16th century Polish cleric and astronomer, and his controversial theory was the heliocentric model of the solar system. He believed that the Earth and the other planets moved around the sun. Now, this was very controversial at the time because the Roman Catholic Church believed the idea that Aristotle said that everything revolves around the Earth. This was totally in opposition to the church. The church was the ruling body at the time. The government and the church were tied. And the dictators or the kings always kept close the clergy because that gave them clout. That gave them the, well, the clergy says, or the reverend says, or the whatever says, whatever religious figure says that it's right, then it has to be right because they believed they had the backing of some higher being. Okay? So Copernicus did not publish his results of the heliocentric model until the year he died, which was 1543. Okay, and it was called On Revolution of Celestial Spheres. So this concludes our first two sections we're going to talk about with Aristotle and Copernicus. Make sure that you have completed all of the work that has been assigned to go along with this video, and I will see you again. Have a great evening.